Given a string S containing just the following characters, determine if the input string is valid. An input string is valid if, and we've got rules here, if open brackets must be closed by the same type of bracket. So our first rule is open brackets must be closed by the same type of bracket. And that means that we have, let's say, a square bracket, it must be closed by the same type of bracket. So that is rule number one. Rule number two is that open brackets must be closed in the correct order. So this means that we cannot have an open square bracket and then a parenthesis, open parenthesis, and then a closed square bracket and a closed parenthesis. So that is rule number two. So what this really means is nested open brackets. So open brackets that are inside of other brackets. Right here we have our outer bracket and our inner bracket. The inner bracket must be closed before the outer bracket closes. So this this closed parenthesis should be right in here between the open parenthesis and the closed square bracket. So that's rule number two. And then rule number three is every closed bracket has a corresponding open bracket of the same type. So this means that we have an open bracket, and then every single bracket is going to have a closing bracket of the same type, and every closing bracket is going to have an opening bracket of the same type. So we could not have, for example, this, right? We could not have this because we have an open bracket that has not been closed. And so we would need to add this in here, and there we go. This passes our third test. So if someone came up to us on the street and said, hey, I'll give you $1 million if you can solve this right here, right now. In this, I'm talking about this string S. How would we solve it? Well, I think the first thing that we would do is look at the very first element in this string. So we would basically loop through the string. We would go through all the characters, right? And we'd say, okay, we've got an open square bracket here. Then we've got this parentheses that basically crosses itself out. This open parentheses is then canceled out or neutralized by this closed parentheses. And then we've got these four characters here. And we can quickly tell, okay, these two square brackets neutralize themselves. These outer curly braces neutralize themselves. And then finally, the square bracket on the end neutralizes the initial square bracket. And this is really easy to solve in our heads, right? But how would we solve this if it was 1,000 characters long? If it was 1,000 characters long, it'd be pretty hard to remember all of the open brackets that we need to close and the order of those open brackets. So what we need to do to solve this, if it was, say, 1,000 characters, is we need to have a way to store the open brackets in order and have a way to tell which bracket type goes with which bracket type. So we have an opening bracket here up in the top left. We have an opening bracket here. And just by common sense, we can determine that this is also a parentheses. So we have this open parentheses, and then common sense tells us, hey, it's the same shape. This is a closing parentheses. They're of the same type. Okay, so we have these two structures or these two processes that are going to help us. The first is keeping memory of the open brackets and the order of those brackets. And the second is determining which closing type maps out to which opening type of bracket. So what we're going to use for memory is a stack. And what we're going to use for mapping out the types together is a hash map. And now a stack is a first in, last out data structure. So if we have some character, let's call it this, this open square bracket, we would put it in the stack, right? And then any character that we put in the stack following it, let's say we put in this, this parentheses, this open parentheses, it's going to go on top, right? So you can think of a stack in a real world situation like a can of Pringles is a stack. The first Pringle that's put in is at the very bottom, and then the last Pringle that's put in is at the very top. And in order to get the last Pringle out, the one at the very bottom, you'd have to take out every single one before it, right? So that's what a stack is. And a hash map is a key value store. So in this hash map, which is called bracket map, we have 3 keys. We have the closing curly brace, the closing square bracket, and the closing parenthesis. And they all map out to the same type, but the opening version of that type. So if we get the value of the key, so right here we are calling bracket map, or it's pseudocode calling bracket map, right? And we're passing in s of I, and s of I is going to be one of our keys over here on the left. And when we pass in that key, the key is either going to be an opening bracket or a closing bracket. Now, if it's an opening bracket, it's not going to be in our key value store. And our bracket map will return null, or it will return undefined, or some other falsy value. But we'll just say for now that this will return undefined, which is a falsy value. And if we pass in a closing bracket, so a closing bracket would be like this third element here in the array, or in the string, or this fourth or sixth element here in the string, or 8th element. What it's going to do is it's going to see, let's take this third element right here, this closing parentheses. Okay, we've got this closing parentheses. The value of that parentheses is an open parentheses, and that's what this bracket map is going to return for us. So that's how we can use this hash map called bracket map to determine the type of bracket that we're looking at. Now, you might be wondering, why doesn't it have all of the keys, or all of the possible characters in the key value? Well, we'll find that out as we go through. So let's go through and actually solve this problem. All right, so just erasing these examples in the stack, we'll erase this stuff up here. All right, great. So now let's iterate through S and see what happens. So we've got this opening square bracket. What we're going to do is on each iteration, we're going to ask this bracket map using this call, hey, bracket map, do you have S of I? So do you have an opening square brace inside of your keys? And it says, no, I don't. So it returns undefined. And if it returns undefined, if it returns a falsy value, we will add this, we will push this onto our stack, this value. And then we'll iterate onto the next value in the string. And so we've got this open parentheses, and we ask bracket map, hey, do you have an open parentheses in your key? It says, no, we do not. So we add it to the stack. And this line here is just to show separation. Then we get to the third character. So we iterate through, we go to the third character in this string, and we see it's a closing parentheses. Hey, bracket map, do you have this closing parentheses in your key store, in your key column? Yes. And so this whole bracket map expression, this whole thing right here, is going to return the value of that key that we passed in. And the value is an opening parentheses, right? So then what we do is we will check, hey, is this open parentheses given from bracket map, is that equal to the top of our stack? Is that equal to the top of our stack? And it is. So if it is, we will pop that value off our stack, we will remove that value off of our stack, the top one, and now we are left with just this square bracket. And we iterate on through the string. And now we have this opening curly brace. Hey, bracket map, do you have it in there in your key column? Nope. So we add it to the stack. And we continue on. We check here. Bracket map doesn't have it in its key column. We add it to the stack. And then we continue on. And there we do have, bracket map does have it in its key column. It's the middle key, as we can see. And so it returns the value of a opening square bracket. It compares that value to the top of the stack. And since they are the same value, it pops it off the stack. We pop it off the stack. And we continue on. We check this closing curly brace here. It's a key. It has a value. That value then equals the top of the stack, as we can see here. So we pop that value off the stack. We pop that value off the stack. And we're left with our opening square bracket, the first element in our string, our day one, you could say. And we iterate through the string. We continue on till the very end, and we find that this closing square bracket is a key inside bracket map. And so bracket map returns the opening square bracket, which equals the top of our stack. So we have to say bye to our day one and erase it or pop it off the stack as we shed a tear. So this string S ends up being a valid parentheses. And it ends up being a valid parentheses because at the end of it, at the end of the string, on our last iteration, the stack is completely empty. There's nothing in it. And at no point did any of the returned values from keys we passed into bracket map not match the top of the stack. They all matched the top of the stack. So for example, let's say that we had a curly brace here instead of this last square bracket. So in that case, let's pretend we're on the second to last iteration. We have our opening bracket on the stack, and we finally get here to our last iteration, and we say, is closing bracket in your key value bracket map? Is it in here? It says yes. And it says yes, and it returns this value here, this opening curly brace value. And so we take that curly brace value, right, and we compare it. We say, hey, curly brace value, is this curly brace value equal to the value at the top of our stack, this opening square bracket? And they are not equal to each other. And therefore, we would return false and stop iterating through the string. And just to reiterate, the reason why we're returning false here is because it breaks rule number two, where open brackets must be closed in the correct order. And the whole purpose of our stack is to keep that order of the brackets. So the element at the top of our stack is always going to be the type that should be closed. Now let's check out another situation here. So let's go ahead and erase this bracket for a second, and we will add our original square bracket. And then we'll add another bracket as well. We'll add an opening square bracket, right? Let's go ahead and erase this under the string so that we can more clearly see which iteration we're referring to here. So let's start at this iteration. And we've already gone through the string, so we know the only character left in the stack is this opening square bracket, right? So during this iteration, what we do is we ask the bracket map, hey, do you have this key and it does, so it returns the value. Then we check that value against the top of the stack, the top element in the stack, and we can go ahead and pop it off. So we pop it off the stack, and then we iterate on. And this is our last iteration right here. So we check, hey, bracket map, do you have this key? And it doesn't. So it returns undefined or some other falsy value. And we then would add, we know that since it doesn't exist in our bracket map, we know that it's an opening character, an opening bracket, and we add it to the stack. And we finally finished. We're at the end of our string. So if we've made it this far, what we know for sure, if we've made it to this point in the string, we know that every single bracket that has been opened has either been closed by the correct type bracket or hasn't been closed at all. So in this case, we have this bracket here that has not been closed, and so we're at the end of the for loop, right? We're at the end of iterating through S. So we actually pop out of our for loop and we check to see if there's anything in our stack. So we say, basically, if our stack is empty, return true. If our stack is not empty, return false. So that's how we solve this conceptually. And let's take a look at the space-time complexity of this solution. So the space-time complexity. Now the space here is going to be O of n, O of n. And the reason for this is that we have two different data structures here. We have a stack and we have a hash map. Now the hash map is of size 3. And so it is actually a constant value. It's of size 3. The string can be of any size. The string is of size n. So the string could be 1,000 characters long, yet our hash map will only ever be 3 characters because we're only ever doing these 3 checks here. So we've got 3 plus the size of our stack. And in the worst case, our stack could end up being the entire size of n, right? It could end up being the entire size of n. Imagine if every single character in our string was an opening bracket. Then our stack would be full of opening brackets, and our stack would be of size n. So it's 3 plus n, and we ignore constants, we ignore lesser terms, of which there are not any, so we move forward with n. So n is our space complexity. Now in terms of time, we are iterating through our input string. So we iterate through each element in the string, and yes, we do operations, so we check the hash map. We have an if-else statement in each iteration of the for loop, but that is not relevant when doing time complexity. So our time complexity is going to be O of n. O of n, because we are iterating through the string, we're iterating through each character in the string. So as n grows, the time it takes to complete that for loop will grow linearly. And that's it. So that is how we solve valid parentheses. Now let's go and implement that solution in both JavaScript and Python. So the first things we'll do is we'll create our data structures. So we've got stack, which is equal to an empty array. And then we've got, what do we call it? Bracket map. Bracket map, which is equal to an object, and the object has 3 properties. So the first, we've got 3 key value pairs, and the first is going to be closing bracket and then an opening bracket as the value. And we'll take this and we can copy this down 2 more times, and fill in the appropriate type. And there we go. So now that we have created our data structures, let's go ahead and open up a for loop. So we'll let I equal 0 while I is less than s.length I++, right? And we will first check, we'll say, okay, if s of I is in our bracket map, s of I is in our bracket map, s of I, then we will have another check, and that check is if that value that we get from bracket map at this character, well, first, yeah, we'll check if does it exist. This is what this checks, and if it does exist, if it returns a truthy value, then we will check to see if that bracket map value equals the top of the stack, right? So we've got stack at stack dot length minus 1, right? And that's going to be the element at the top of the stack. So if that returns true, or actually if this is false, right? So if this is not the case, we know for sure that our string is not a valid, it's not a valid parentheses, or it's not a valid string, right? So we can just return false right here. And if this is not true, what we want to do is, since the value of the hash map matches the value at the top of the stack, we want to pop that value off the stack. So we will say stack.pop. And that will simply pop the last element in the array, right? The last element in the stack. And what we'll do now is we'll create an else clause here, and we'll say, well, basically, if this returns a falsy value, it means that it's an open bracket. So we just want to stack.push. We want to push onto our stack s of I, right? And that's all we really want to do. So we have this else, and then we have a for loop. And now we know, after going through this whole for loop, we know that there's no opening bracket that had a mismatched closing bracket. But what we don't know is that there may be open brackets still on our stack that never got closed, right? So what do we want to do here? What are we supposed to return? Well, we want to return true, hopefully, but only true if our stack is empty, right? So an easy way we can do that is just write a conditional here. We can say return if s.length is equal, or sorry, stack.length, right? Because we're checking the stack. If stack.length is equal to 0, if this conditional is true, it will return true. If it is false, it will return false. And so there we go. So let's go ahead and make sure that this works. Let's submit it like we just don't care. Beautiful. Okay, great. And now let's go ahead and solve it in Python. So the first thing we want to do is create our data structures. And we don't use const. This is Python, so we will say stack equals, we'll set it to an empty list, which is similar to an array in JavaScript. And then we'll say it is bracket map equals, and we'll set it to a dictionary, which is similar to an object. It's similar to an object in JavaScript. It's a key value store. So we will set the closing brackets as the keys and the opening brackets as the values, as we did in JavaScript. And there we go. So now we can open a for loop. So for I in S, and since we're checking through a string here, we can use the in keyword for I in S, where I is each element in S, right? And so we'll say if I is in bracket map. So that's how we check to see if I is inside a bracket map. And this right here will return true if the key is in that bracket. So if I is a key in the bracket, it will return true. And therefore, we want to create a new if statement and say, and do our check to make sure that the bracket map value and the element at the top of the stack are the same character, right? So if bracket map, so we can say bracket map at I is equal, or actually is not equal, let's say it's not equal to the top of the stack, we want to return false. So we'll say stack, and in Python, the way to get the last element in a list is just by putting a -1. So stack at -1, we want to return false. And actually, what we also want to do here is, unlike in Python, in JavaScript, if we check an element inside an array in JavaScript, we'll get undefined if that element doesn't exist. So let's say we had an empty array in JavaScript and we looked for, you know, an element in it, like we passed in, you know, get array or get index of I or get index of 1 or any arbitrary value, but the array was itself an empty array, it would return undefined. Here, if stack is empty and we call this, it's going to return a runtime error, index out of bounds, so, or index out of range. So what we want to do is we want to make sure that stack is not an empty list. So the way we can do that is to say not stack. So if stack is empty, it will return false here, and this not will make this false true. So if this is true or this is true, we want to return false. And the reason why we want this, another reason why it's nice to have this, is because it's actually checking if our value is not, if the stack is completely empty, right? If the stack is completely empty, then it's impossible for the value of this bracket map, of the key of this bracket map, it's impossible for that value to exist in a stack that's empty, right? So we're checking for, we've been passed in some sort of closing, one of the 3 types of closing brackets, and we are checking to see if that is the top element in the stack, but the stack doesn't even have anything in it, right? So obviously it can't, it cannot be true because the stack is completely empty. So we'll move on. We'll have an else clause here, and what we want to do here is just pop the top element off the stack. So we'll do stack.pop, right? And now the other else we want is if I is not in bracket map, meaning I is one of the opening brackets, And in that case, what we want to do is we want to stack.append. We want to stack.append the value of I, right? And so that's all we need to do. And lastly, we want to return, well, we want to return true. Hopefully we're returning true if the string, the input string passes as a valid parentheses string. However, remember, we want to make sure that at the end of our for loop that our stack is completely empty, meaning all of the opening brackets had been met with closing brackets, and that our stack is completely empty at the end of iterating through S, right? And so the way we can return this is very similar to JavaScript. We will have a conditional just like JavaScript, and that conditional will be the length of stack is equal to 0. And if this is true, if the stack is empty, then we're saying, is it equal to 0? That means that this would return true. If the stack is empty, it has a length of 0, and ultimately it would then return true out of our function. And if it is false, if stack has at least one value, then this conditional will return false, and then we will return false out of our function. So let's be ballsy and just submit it and pray to the heavens that nothing was wrong. Damn it. Okay, so let's see what's going on here. You know what? We don't actually want this else here. That was my mistake. We want to just have stack.pop here. And this was an indentation level error anyway. So let's go ahead and submit this, and hopefully it works. Indentation error does not match any outer indentation level. Okay. Hopefully this is it. I think it was just one space off. And this looks like it's one space off as well. And then this for loop, I can already tell that should do it. But I feel I'm going to eat my words. Oh no, look at that. Okay, so that is how you solve it in Python.